I think I've started every video on the unit circle by saying that this is like a cool thing about the unit circle, because I actually genuinely think it's pretty cool. But I'm gonna not start this one with that, but I'm gonna tell you, I think this is pretty cool. Okay, so if we think about how we created the unit circle, we took those special right triangles and we placed them all around the unit circle. And if you don't remember that, you can go back to the creation of the unit circle video. But we can learn some pretty cool things from the unit circle. And so we're gonna learn something today, and we're gonna call them our trig identities. And so these are like important, true mathematical statements that are always held true, okay? And so if you remember way back when, and by way back when I mean sophomore year, maybe freshman year, you learned something called the Pythagorean theorem. And the Pythagorean theorem goes a squared plus b squared equals c squared, okay? And it only works for right triangles, only works for right triangles, remember that, okay? And so what we learned in our unit circle video is that whenever we have sine of something, it's just equal to our y coordinate. And whenever we have cosine of something, it's equal to our x coordinate, okay? And then whenever we have tan of something, tan is always y over x. So we have this triangle right here. We know it's a right triangle, right? It's one of our special right triangles. We know that the hypotenuse is 1 because the hypotenuse is also equivalent to the radius of the circle. And if this is a unit circle, a unit just means 1. So our radius has to be 1. Okay? And so we know that if this is our y coordinate right here, right? This distance upward represents y. We're just going to call that sine of this angle theta. And we know that angle right now, but we're just going to leave it as theta. And so if this is sine, right, because it's our y, our distance up, then our distance across is x, and our distance across has to be cosine, right? That's what we figured out the last video. We're going to go from here. So cosine of theta. So we can plug these trig functions and this one into the Pythagorean theorem because this is a right triangle. Okay, if this weren't a right triangle, then we would not be able to do it. But because it is a right triangle, we can. So I'm going to plug in and say sine of theta, and I'm going to square that whole thing, plus cosine of theta, and I'm going to square that whole thing, equals 1 squared. So when we square the function sine of theta, it doesn't become like sine theta squared. That would be saying square the angle and then take the sine of it. How we write it is sine squared theta plus cosine squared theta equals 1. So this is our first trig identity, right? This holds true no matter what. And so we have these trig identities because if I wanted to go from cosine to sine to tan to other trig functions that I'll talk about in about 30 seconds, these are really helpful in manipulating all of the functions so I can solve for one in particular. So if I wanted to get sine alone here, or sine squared alone, I'd subtract cosine squared from both sides. And then I could plug in cosine, or 1 minus cosine squared theta for anything that said sine squared, okay? So I'm just gonna write down our first trig identity here. So sine squared theta plus cosine squared theta equals 1. And what is also important is that we have more than just sine, cosine, and tangent that are trig functions. And you might not have learned them in sophomore year. I don't think you did. So we're just going to hit on them right now. So we have sine, and we know sine equals y, right? We just talked about that up there. We have cosine. We know cosine equals x. And we have tan, and we know tan equals y over x. So you've definitely learned those. But what you might not have learned is something called cosecant. And cosecant equals 1 over sine. And if sine is y, then this just equals 1 over y. We have secant, which equals 1 over cosine. And we know cosine is x, so 1 over x. And then we have cotangent. And cotangent equals cosine over sine, which we can then say equals x over y. So these are our 6 trig identities or trig functions. And we are going to, we've already found one trig identity. We're going to find the other 2. And so the other 2 just involve taking our initial one from the Pythagorean theorem and dividing by cosine squared or sine squared. So if I'm going to divide by sine squared theta, we're going to watch what happens. So I have sine squared theta plus cosine squared theta equals 1. And I'm going to divide each part by sine squared theta. Because if I'm going to divide the whole thing, I have to divide each one individually. I can't just divide like sine squared on this side and 1 over there. I have to do divide by sine squared for everything. Otherwise, it makes this statement mathematically incorrect. Okay. So sine squared theta divided by sine squared theta, they cancel, right? If I have an x and I divide by an x, it gives me a 1. If I have a 2 and I divide by a 2, it gives me a 1. So sine squared theta divided by sine squared theta gives me a 1. And then I have cosine squared theta over sine squared theta. And we know down here that cotangent is cosine over sine. So this is going to turn into cotangent squared theta. And we know that 1 over sine is really cosecant. And so cosecant squared is what this is going to turn into. Okay, so our next trig identity is 1 plus cotangent squared theta equals cosecant squared theta. So that's my second trig identity. And then my third trig identity is going to be if we divided our initial trig identity by cosine squared. And I think my handwriting is only getting worse throughout this. So I have sine squared theta plus cosine squared theta equals 1. And I'm going to divide this by cosine squared theta, divide this by cosine squared theta, and then lastly divide that 1 by cosine squared theta. So sine squared over cosine squared, right? We know that sine over cosine is tangent. So this gives me tangent squared theta plus, well, we just talked about sine squared theta over sine squared theta just gives me a 1. So cosine squared theta over cosine squared theta gives me a 1. And then 1 over cosine squared theta gives me a secant squared theta. So this is my third trig identity. And we just got the second and third one solely by taking the first one we derived from the Pythagorean theorem and dividing by the different functions. Okay, so here are our three trig identities. How we got them is over here. Okay. And then our important 6 trig functions, but we may have only known 3 up until this point, are over here.